Hi and welcome to Gaffy's Grinds. This is video 8 in our series on atoms, elements and the periodic table for Junior Cert Science. A quick reminder, if you've got your phone on you, you should definitely turn it off, put it in another room to stop you from getting distracted. And when I ask you to do the tasks, you should make sure that you do them. If you don't do them, you're wasting your time, you're not going to learn as much. Last thing, I suppose, this is video 8 in this series, so if you're jumping in here, some of the concepts may be harder to understand if you haven't watched the first 7 videos, so it's probably a good idea to do them in order. Right, with that in mind, we're going to start with a quick quiz. We're going to make sure that we do some more practice on stuff you should already know from the previous videos. So I've got 5 questions here. What I want you to do is I want you to pause the video and answer the questions in your copy now, please. In full sentence answers, please do that now. All right, so you should only be watching the video if you are playing, if you have tried to do all of the questions. And we're going to go through the answers quickly now. The way I'm going to do this is I am going to tell you some things you should have in your answers. I'm not going to give you absolutely every single word. I'm not going to write a full sentence, but I'm going to say what you should definitely include in your answer. Okay, so what are atoms made of? Well, you should definitely have the subatomic particle names. So you should have proton, neutron, and electron. Okay, so you should definitely have those 3 in your answer. What are atoms made of? They're made of protons, neutrons, and electrons. What makes up the nucleus of an atom? Okay, so which of these 3 make up the nucleus of the atom? So if you didn't mention these 3 in the first one, we weren't sure where to go, you should definitely write an answer to number 2 using those words now. Pause the video and do that. All right, so making up the nucleus of the atom are the protons and the neutrons. Protons and neutrons are found in the nucleus. Well done, if you got that right. What do you find orbiting the nucleus? Well, that would be the other subatomic particle, electrons. Again, if you're getting all these right, well done. You know your stuff. What is an element? So this is going back to the very first video on this topic. So what was an element? So an element is made of one type of atom. Okay, so a substance made of only one type of atom or all the same type of atom. So it's a piece of a substance and there's only one type or all the same type of atom in there. That's what an element is. So you have to have that phrase in your answer, one type of atom. Where can you find all the known elements? Okay, so we find that on an organized list that we call the periodic table of elements. So again, you have to have a periodic table in your answer. If you've got that, make sure you tick them. And if you don't, make sure you rewrite the answer and include this in your answer, include these terms. Now, like I said, you should have a full sentence. These are just the key bits. There's no point in you just taking on the key bits. You should have a full sentence answer because, again, that helps you link ideas. It makes you better at writing science stuff. Okay, into today's lesson. Okay, today we're going to learn about things called elements, compounds, and mixtures. All right, here I am drawing a particle. The type of particle it is an atom. It's an atom, and I know it's an atom because it's just one circle or one disk. So this is a very simple representation of an atom. Here, I am drawing a second atom. This is a second atom. Both of these are particles. They are atoms. What happens when they come together and they stick together by a chemical bond? They chemically bond together. So this here is showing a chemical bond. This is how we show that they are chemically stuck together. Now we have a new type of particle. We've got a group of atoms, so at least 2, stuck together. We call this type of particle a molecule. This is a molecule because it's a group of atoms chemically joined. Group of atoms chemically joined, we call this a molecule. So that's what this particle is, this group of 2 atoms. Now, you will notice that both of the atoms are the same. So we've got 2 of the same type of atom. So above, we've got 2 individual atoms. Below, we've got a molecule which is made of 2 of the same atom. So what type of substance is this? Well, it's only made of the same type of atom, or one type of atom. So what type of substance is this? On three, 1, 2, 3. Okay, you should be saying element. This is an element because it's only made of one type, or it's made of the same type of atom. So up the top here, we've got two atoms of an element, and below they've joined together to make a molecule of an element. Let's look at another one. Here, I have a particle, and it's got this lined print. Here, I've got another particle, and it's got the same lined print. Okay, so I want you to tell me what type of particles are both of these. So on three, 1, 2, 3, what type of particle are they? Type of particle that they are, you should be saying, is an atom. Each of these is an atom. It's an individual atom. They join together, and they make a new type of particle. Two of these atoms, the same pattern, join together to make a new type of particle. What do we call this particle? Speak your answer on three, 1, 2, 3. Okay, you should be saying this is a molecule. Well done. If you said molecule, good job. It's a molecule because it's a group of two or more atoms that are chemically joined. Remember, they are stuck together. This shows a chemical bond. Chemical bond. What type of substance is this? So on three, speak your answer to the screen. 1, 2, 3. This, hopefully what you said is, this is an element. It's an element because, again, it's only got the same type of atoms. It doesn't have any other types of atoms in here. Same type of atom. It's an element. So an element is a substance made of the same type of atom. We already knew that, but I suppose what we now know is you can have atoms of an element, or you can have molecules of an element, depending on what the particle is like. If it's a single atom, we say an atom. If it's a group of atoms, we call it a molecule. Great, we're going to make it a little bit more complicated now. Okay, so what happens if I start with two particles, but they are now different types of particles? So I've got an atom of this white disk, an atom of this white atom, and I've got a lined atom or a pattern atom. When they join together, they are going to make a molecule. This is still a molecule because it's two atoms chemically joined together. So this here is a molecule. Again, we know it's chemically bonded because the atoms are touching. This is a chemical bond. So it's a molecule. But this time, what type of substance is it? Well, we know it's not an element because it's got more than one type of atom. So where we have a substance that's got different types, we've got different types of atoms. And another way of saying this is if we've got different types of atoms, then that must mean you could replace the word types of atoms with different elements, because each atom, each type of atom is a different element. Different types of atoms or different elements, and they are chemically joined together. So we know they're chemically joined together because they are touching. So they are chemically bonded. Chemically bonded. We call these types of substances compounds. So they are called compounds. So this here, different types of elements or different types of atoms chemically combined or chemically bonded are called compounds. So up here on the top, this is an atom of an element. This is an element because there's only one type of atom here. This is an atom of a different element. Together, they join together to make a molecule of a compound. Make a molecule of a compound. What I'm going to do is I'm going to get you to pause the video, and I'm going to get you to take down the diagrams, and the definition there. So pause the video, do that now, please. All right, we're going to take another look, a look at a different way of writing this. So say we have 3 atoms of lithium. Now this is just a different way of drawing atoms, but above I was using patterns. This time I'm going to use the chemical symbol. So this is 3 lithium atoms. This here is an example of an element. Now it's a molecule of an element because it's a group of atoms that are joined, they're touching, but they're all the same type of atom. So this is still an element. If I was to take the lithium, one of them atoms, and I was to join it with another element. So for example, element fluorine, LiF. This here would be a compound because we've got 2 elements and they are chemically joined together. This is a compound, a molecule of a compound. Now note, if I have a lithium atom and a fluorine atom, and they are in the same area, I'll put them in the same container, but they're not chemically joined together yet. They haven't actually attached to each other. Well, if we look at the definition here, for a compound, we must have different types of elements and they must be chemically bonded. These here are not chemically bonded. So this here is not an example of a compound. It is not a compound because there is no chemical bond. I'm going to look at one more example now. Say we have this substance here, carbon. And carbon is chemically bonded to 2 oxygen atoms like this. This here, is it an element or a compound? So speak your answer to the screen on 3. 1, 2, 3. Hopefully you said that it's a compound because we've got different elements, carbon and oxygen, and they're chemically combined. We call this compound carbon dioxide. Call it carbon dioxide. Now there's a hint here in that there's actually in the name carbon. That's one element, that bit of it. And then the second part of the name shows, well, di, this bit here, this just means 2. So di means 2. And then oxide refers to a different element, oxygen. So the name kind of gives us a hint that there's actually more than one element here. So if you look at that name, carbon dioxide, that's 2 elements. So it can't be an element. So it must be a compound. Now, how do we know for sure something's a compound? Well, we know that all the elements are listed on the periodic table. So we know that that's what the periodic table is. It's a list of all the elements. So if I was to open up my periodic table, I've got one at the back of my book here. If I was to open up my periodic table and have a look through all the elements, I would not find carbon dioxide anywhere. I would find carbon and I would find oxygen, but nowhere there is there an element that's carbon dioxide. So only elements are listed on the periodic table. You wouldn't find any compounds listed there. So there's a couple of ways you can work out if something is an element or not. If you can look at its diagram like this, C and 2 O's, you can see, oh, there's 2 elements. You can look at its name, carbon dioxide. Well, I can see 2 element names in there, carbon and oxygen. So this can't be just an element. And sometimes you can look at the formula. So for example, I don't want to make this too complicated because we'll do this again. But if you look at the formula and you see CO2, well, that's C is one element, carbon, and O is another element, oxygen. So again, it can't be just an element. So it has to be compound. All right, I'm going to get you guys to do some practice now. All right, so I've got this substance. What I want you to do is I want you to write it down in your copy, draw this, what I've drawn, and I want you to write beside it, is it an element or a compound? I want to know, is it an element or a compound? Pause the video, do that now. Okay, hopefully you said this was an element. Only got hydrogen. I'm going to do 2 more now. So this one and this one. Pause the video. Tell me, are these elements or are they compounds? Okay, so you should have drawn this here, two O's, and you should have been saying that this was an element because it's only got oxygen atoms. It's a molecule of oxygen. It's a molecule because it's got more than one atom chemically joined. This here, this is a molecule as well. It's three atoms joined together, but it is a compound because it's different elements that are attached to each other. All right, you ready to do some practice now? All right, so I've got a question set here for you guys to do. Maybe I'll just zoom in on the first 5 first. We're just going to do the first 5. So pause the video and do 1 to 5 just first for me. Okay, so you should only be playing the video if you've done questions 1 to 5. A substance is made of 3 different types of atoms. Is this an element or a compound? Well, it's the key here is that it's 3 different types. So it's going to be a compound. Well done if you said that. Next one, a substance is made of 3 of the same type of atom. So is it a molecule? Is it an element or a compound? It's an element. Well done if you said element. What is the main difference between elements and compounds? So element, one type of atom. That's what you should be saying. And compound, you should have said different types of atoms. Different types. So if you're asked for the difference, the main difference, you can literally just give the 2 definitions. So the main difference between elements and compounds, give the definition of an element, the definition of a compound. Element is one type of atom, is made of only one type of atom. Compounds are made of different types of atoms chemically combined. Is magnesium oxide an element or a compound? Well, the clue is in the name. Magnesium is one element. Oxide comes from oxygen, is another element. Those 2 elements has to be a compound, can't be an element. So well done. If you said that, good job, correct it. If not, fix it. What are the names of the 3 subatomic particles that make up atoms? Protons, neutrons, and electrons. You should have that in your answer. If you've got that in your answer, well done. Good job. Okay, a couple more questions for you to do now. I'm going to hide numbers 1 to 5 now. 1 to 5. So you've got questions 6 and 7 to do. Okay, question 6. Let me just show you how it's done. Okay, and then I'll get you to pause it and do the questions. It says there are 5 sentences below. Some are true and some are false. All you have to do for each one is say whether you think it's true or false. Okay, that's all you have to do. Ignore that bit maybe about saying why. I just want to say, how do you know if it's true or false? I'll just say, sorry, if it's true or false. So the first one, if you want to know if a compound, if you want to know the name of a compound, you should look it up on the periodic table. Is that true? Would I find the name of a compound on the periodic table? Well, I've already told you that the periodic table is a list of the elements. So if I want to know the name of a compound, I'm not going to find it on the periodic table. So this is false. Okay, it's false. How do I know? Because I wouldn't find compounds named on the periodic table. I only find elements. So that's how you do it. You do the rest. And then for number 7, you have to look at the diagrams and say if they're elements or compounds. So looking at the diagram, are they elements or are they compounds? So I want you to pause the video and do that now, please. All right, let's go through them. You should only watch it if you have done these questions. Again, if you're not going to do the questions, you're wasting your time watching the video. A lump of iron is an example of an element. Yeah, well, it says iron. So if I want to know if it's an element, I go to the periodic table. I can see iron is an element on the periodic table. It's Fe. I can find it there. So it is an element. This is true. Table salt is made of sodium and chlorine atoms joined together by chemical bonds, and therefore it is a compound. Well, if it's made of 2 types of atoms joined by chemical bonds, then that is definitely a compound. So it is true. Well done if you said that. If you want to make an element, you need to take different types of atoms and chemically bond them. So if you want to make an element, you need to take different types. Now that doesn't sound right. Different types of atom won't give me an element. That will give me a compound. So if I want to make an element, that is not what I would do. So that should be false. Well done if you said false. A piece of tellurium is an example of a compound. Tellurium is a compound. Is that true? Well, that would be true if I can't find tellurium on the periodic table. Now, I know that tellurium is an element. I just need to find where it is. Tellurium. Okay, so it's element number 52 if you've got your periodic table. It's got the symbol Te. So it's got a chemical symbol Te. Te is tellurium, and it is an element on the periodic table. So a piece of tellurium is an example of a compound. This is going to be false because I find that on the periodic table, so I know it's an element, not a compound. So that's false. All right, let's look at number 7. Are the following substances elements or compounds? Well, number 1 is all the same type of atom, so that's an element. We did this picture before, you might remember early on, where we just said if it's an element or not an element. So today, we now know if it's not an element here, they're going to be called compound instead. The second one, has 2 different types of atoms chemically joined, so that's going to be called a compound, not an element. The next one, we've got 2 pieces, but they're all the same kinds of atoms. So there's still an element. There's not a second type of atom there. The next one, we've got 4 different atoms. We've got 4 atoms. They're separate, but they're all the same. We call this an element. E has molecules, so groups of 2 atoms, but all the atoms are the same. So again, it's element, molecules of an element. And the last one, F, well, F has 4 atoms and are different kinds of atoms and are chemically joined. So this is a compound. So great job. Well done if you got those right. I'm going to make this a little bit more complicated now. All right. So remember that we talked about this guy here a few minutes ago. This here is an oxygen atom chemically joined with 2 hydrogen atoms. Is this an element or a compound? Speak your answer to the screen. This is a compound. Well done if you said compound. And these here show chemical bonds where the elements or the atoms are touching, chemical bonds. This substance here is called water. So that one might be hard just from its name to recognize that it's a compound because it doesn't have the name of 2 elements in there. But if you went looking for water on the periodic table, you're not going to find an element called water. So it has to be on the periodic table if it's an element. If it's not, then it's definitely not an element. It could be a compound. Now, you will know what water is because you will definitely have drunk some today. If you don't drink this, you're in trouble. You need to stay hydrated, drink water every day. So this is a compound we're very familiar with. Keeps us alive, keeps us hydrated. It keeps our chemical reactions happening inside our cells. But I could also have these same 3 atoms, oxygen, hydrogen, and another hydrogen. I could have these same 3 atoms in a container, but here they are separate. There is no bond here. They are not touching, or there's no lines connecting them. When we have a situation like this, we don't call it a compound because for it to be a compound, the atoms have to be chemically combined. We call this a mixture. This is a mixture. So the atoms are put together, they're in the same area, the same general area, but they're not actually chemically combined. Now, it can be more complicated than this. So if we take an example, say we have a box. And inside the box, we've got these substances. We've got that, and say we've got that. Now, you will see that up here, we've got an element, 2 hydrogen atoms. They're the same atom, so this is an element. And down here, well, this is a compound. It's water again. But if I was to ask you what's in the box, Well, the box contains different substances. It's got this hydrogen up at the top and it's got water down at the bottom, but they are not chemically combined to each other. We've got different substances not chemically combined, or chemically bonded, probably is a better word, chemically bonded. Different substances not chemically bonded. We don't have any attachment between these two. These aren't attached to each other. They're separate. There's no bond. When we have something like this, we call this a mixture. We call this a mixture. So a mixture is where we have different substances together but not chemically bonded. That is a mixture. All right, so I'm going to get you to pause the video and I'm going to get you to take that down. So the diagram and the definition. Let's look at another example. Okay, so say we have a beaker. So this is a beaker, and in the beaker, we've got some water. Water is a compound, which we've seen already. We've got water, and it's a compound. We're going to take some sand. We've got this little pile of sand. So this yellow pile is a pile of sand. I don't want it to do that. Got this yellow pile of sand. This is sand. I'm going to take that sand and we're going to put it in the water. What happens is the sand settles to the bottom. It does not make a new substance with the water. They do not make a new substance. They do not chemically combine. We say we have a mixture. And we would call this mixture sand and water. A mixture of sand and water. And whenever you see "and," then that's a pretty good clue that this is a mixture we're talking about. We haven't made a new substance. We're calling this sand and water. You might call, try and think of another example. I don't know if anybody else does this, but when I watch a movie, I like to eat popcorn and like M&Ms or crispy M&Ms, something like that. And what I sometimes do, and I know this might be weird, but you should try it if you haven't. You take your popcorn and you pour in, so you've made it, especially the microwave popcorn, it's still warm, and you pour in your M&Ms in the same bowl as the popcorn, and it kind of warms up the M&Ms and makes them a bit melty. So in that case, I've got a bowl of popcorn and the M&Ms. I haven't made a new substance, which is like a compound of M&Ms and popcorn. It's not like there's a new thing I've just made. It's just a mixture, and it's really easy to separate them. I can literally pick the M&Ms out, or I can pick the popcorn out. So mixtures tend to be really easy to separate. If you think back to how we separate things, we separate mixtures quite easily. So if I wanted to separate this mixture, sand and water, I could just filter it. The water would go through the filter paper, the sand wouldn't. Easy to filter. And this is because, like this, there is no connection between the different substances. They are not chemically joined together. So it's easy to take them apart. Whereas if I went up and I tried to separate this, if I tried to separate these atoms here, well, these atoms, sorry, up here, these atoms are chemically joined. It's much harder to separate them, but it's easy to separate them when they're not chemically joined. All right, time to do some more practice. Here we go. Okay. All right, let's have a look at number 1 first of all. All right, so what you have to do is look at the box and say whether the contents of the box is an element, a mixture of a compound or a compound. And number 2, I want you to tell me, how do you know? Okay, so is it a mixture, element, or compound? How do you know? Pause the video, do that now. Okay, so hopefully you've said that this was a mixture. It's a mixture. How do you know? Is question 2 down here. How do you know? Well, it's got 2 or more substances. It does have 2 or more substances. So here's one substance, the oxygen. Here's another substance, the nitrogen, and there's quite a few of them. Here's a Another substance, the water. Here is, oh, I've got actually another nitrogen to color in. And here is a final substance, argon, or carbon dioxide, sorry, here. All right. Now, there's two or more substances, and they are, which are not chemically combined. Which are not chemically combined. That's how I know it's a mixture. Two or more substances not chemically combined. Now, this here is a mixture of stuff and all gases. We call this mixture here, this mixture is actually air. It's the air that we breathe. We've got oxygen gas, we've got nitrogen gas, we've got water gas, water vapor basically, water is a gas, and we've got carbon dioxide. Now, you will notice that I've drawn mostly nitrogen because air is mostly nitrogen. It's about 80% nitrogen. It's about roughly 20% oxygen, and that's nearly 100%, by the way. And then we've got a very, very, very tiny amount of carbon dioxide, water, and there are some other gases in there as well, but those are kind of like the really, really, really small quantities. So this here is air. Now, the reason why I'm showing you air is because this is a mixture that doesn't have the word and in the answer. So it's not like sand and water. That's really easy to tell that that one's a mixture because it doesn't have a special name. Whereas this mixture does have a name that we call it air. So it's just a little bit, you do have to be aware that some mixtures do have their own name, and that doesn't mean that they're a compound. So they can still, you just, I suppose air is one you're probably just going to have to learn. Okay. All right. So the last question I have for you is, for each of the substances below, I want you to say whether it is an element, a compound, or a mixture. So I want to pause the video and do those now, please. Okay. All right. So water is a compound. Well done. If it said compound, water is a compound. It's not found on the periodic table, but it does have atoms chemically combined, different types of atoms. Salt and oil. Well, the key is in the and bit. If I mix together salt and oil, I don't make a new substance. I just make a mixture. Well done. If you said mixture. Ammonia. That one might have been difficult for you, but ammonia is a compound. We won't find it on the periodic table, so it's a compound. Nitrogen. Well, this is on the periodic table. It is an element. Well done. If you said element. Calcium. Got to check if it's on the periodic table. It is on the periodic table. It's an element. Well done. If you said that. Methane is not an element. You won't find methane on the periodic table. It's a compound made of carbon and hydrogen. So it's a compound. Methane is a compound. Sandy water. Well, this is the same as sand and water. So what is this going to be? This is a mixture. Well done, if you got that right. Ice cube in a glass of water. Ice cubes in a glass of water. This is a little tricky one. Have a really good think about this now. I am telling you, it's a little bit tricky, this one. So just have another little think. Pause the video and really think about it. Okay, so ice cubes in a glass of water. Ice cubes are just solid water. And then you've got a glass of liquid water. So you might have said mixture, and I see why you might have said mixture, but actually it's just water in water. So we've got solid water in liquid water. It's just a compound, because water is a compound. It's just a compound, and it's solid version of the compound and a liquid version of the compound. So it's technically not a mixture because it's not got different substances. It's all the same substance. That was a little tricky one. So sorry if that one caught you out, but I just wanted to get you thinking. The next one, ice cubes, but this time in a glass of Coke. So it's not ice cubes in water this time. Okay, so this one is a mixture because you've got water in the ice cubes and Coke is the liquid. So those are different substances. So that is a mixture. It's easy to separate them. You can just put your hand in and take the ice cubes out. Cement, which is sand, water, and gravel. This is going to be a mixture. That one is probably tricky, as it might have been tricky to understand, but it is a mixture. It's just a mixture of sand, water, and gravel. They don't all combine to make a magic new substance. It is a mixture that goes hard and it holds stuff together, but it's not a new substance. So correct your answers, either tick them or fix them. Well done. I hope you managed to do pretty well on those questions. And I will see you in the next video. Please do leave a like and subscribe. It does help the channel. It will help this channel to help other students, and that's what we're all about. So thank you guys. I'll see you in the next video.